Okay, students, good morning to all of you. Myself, Dr. Santosh Choudhury, reader in chemistry. And today we will discuss the organic chemistry, haloalkane, haloarenes, the class number 7. In class number 7, we will discuss what is haloarenes. You know, last class we discussed about the characteristics of alkyl halides. In characteristics of alkyl halide, we discuss the elimination reaction. Means generally alkyl halide undergoes elimination reaction, means dehydrohalogenation to form corresponding alkene by losing a molecule of halogen acid, which is known as dehydrohalogenation. Okay. And we will discuss the reaction of alkyl halide with metal. When the alkyl halide react with the metal, it undergoes the Wurtz reaction, and when react with magnesium, it form Grignard reagent. And you have to discuss we have already discussed the alkyl halide is a key compound for the organic chemist. That means from alkyl halide we can synthesize the various class of aliphatic organic compound such as alkane, alkene, alkyne, alcohol, ether, ester, primary amines, carboxylic acids, nitroalkanes, alkanitrile. So many class of organic compound can be synthesized from alkyl halide. Today you will start to discuss the haloarenes. And haloarenes means it is the halogen derivative of benzene. So what is the halogen derivative of benzene? You know the molecular formula of benzene is C6H6. The halogen derivative of benzene means the hydrogen atom of benzene molecule replaced by halogen. So this became C6H5X, and this X is equal to generally fluorine, chlorine, bromine, iodine. And this is halogen derivative. This is known as haloarene or aryl halide. The reactivity of aryl halide is quite different from alkyl halide, as the halogen atom is substituted in the benzene ring. Means the halogen atom bonded to the sp2 hybridized carbon atom. Okay. So what are the halogen derivative of benzene or haloarenes? This is your benzene ring, and one of the hydrogen atoms substituted by chlorine. Suppose the hydrogen atom of benzene ring is substituted by bromine. The halogen atom of benzene ring substituted by iodine. Or you can say the halogen atom of benzene substituted by fluorine. Not only the haloarenes means not derivative of halogen derivative of benzene, it may also the derivative of CH3Cl, that is derivative of toluene. Toluene means methyl benzene. It may be this is also say halogen derivative of benzene. This is called dihalogen derivative. as there is two numbers of chlorine atom, that's why it's called dihalogen derivative, and the dihalogen derivative again 3 times. Okay, so these are the halogen derivative of benzene. Next come to the nomenclature. The nomenclature of haloarene, same as there are halogen derivative of alkane, that is benzene. The parent molecule, it will change to halobenzene. Means this is called chlorobenzene, and this is called bromobenzene, and this is called iodobenzene, and this is called fluorobenzene. Okay, what is this one? You say this is one, or this is, that is called chloro, this is called orthochlorotoluene, because this position is called ortho, nearby position is called ortho. And what is this one? This is a dihalogen derivative, and the dihalogen derivative, this is called ortho dichlorobenzene, or you can say 1,2-dichlorobenzene. Similarly, we can say this is meta-dichlorobenzene, or 1,3-dichlorobenzene. Can you name this now? This is 1, 2, 3, 4. This is called 1,4-dichlorobenzene, or para-dichlorobenzene. These are the nomenclature. The nomenclature of haloarenes in common system as well as IPEX system almost same. So now I will give an example. Suppose CH2Cl CHCl2 CCl. If these are haloarenes or not. Mind it, although these are containing the benzene ring, but not haloarenes. These are simply a class of alkyl halide, that is benzylic halide. These are not. That means haloarenes means the halogen atom must be substituted into the benzene ring, not in the side chain. If it is substituted in side chain, then they are said to be alkyl halide, That means a class of benzylic halide. So these compounds are not haloarenes because the halogen atom not substituted in the nucleus of benzene ring. Then you can say, suppose you will take this one. Remember, these are both the same molecular formula. But this is haloarenes and this is alkyl halides. And the reactivity of this halogen is quite different from the reactivity of this halogen. Means this halogen undergoes easily the nucleophilic substitution reaction, but not this one. So the halogen atom when bonded to or when substituted to the nucleus of benzene, then only we can say this is haloarenes. Now what is now this compound? This is called, you can write in IPEC system, this is chloro phenyl methane. You saw this is your methane molecule, and this methane molecule is substituted by a phenyl group as a chlorine atom. Thus it's called chlorophenyl methane. And this is called dichloro phenyl methane, and this is called trichloro phenyl methane. So what is this trichlorophenyl methane? That is 3 chlorine atom is there, and phenyl group means this group is called phenyl group. That's why it's called trichlorophenyl methane. In common name, common system, this is called benzyl chloride, and this is called benzyl chloride, and this is called benzo chloride. This is monosubstituted benzyl. Benzyl means disubstituted, and benzo means trisubstituted. Okay, students, this is our haloarenes, and their classification, they are classified as mono, di, tri, depending upon number of halogen atom. The halogen atom must be substituted in the benzene nucleus, and these compounds are named according to their common name as well as IPEC system. Next we come to the preparation method of preparation. How this? Particularly we are using the chlorobenzene. The first method, that is, it can be prepared from benzene. The benzene can be converted to halobenzene by halogenation. Halogenation means the hydrogen atom of benzene molecule is substituted or replaced by the halogen atom, that is called halogenation. Again, the halogenation is 3 types. One is called chlorination, bromination, and iodination. That is, chlorination means you can prepare the chlorobenzene, and by bromination you can prepare bromobenzene and iodination, you can prepare iodobenzene. And the iodination is a slow process and reversible in nature. Means reversible, the reactant are react to form the product and product are react to the reactant reversible reaction. If it is a reversible reaction, then it can attain the equilibrium. To make irreversible the iodination, we are using some, that is irreversible. It became irreversible in presence of oxidizing agent like concentrated HNO3 or HIO3 iodic acid. Okay, the halogenation means the benzene treated with the corresponding halogen in presence of a suitable halogen carrier. That means the halogen carriers is anhydrous aluminum chloride, anhydrous ferric chloride. Okay, these are the what? Halogenation. So let us see how the halogen is taking place. The halogen is taking place that is benzene treated with chlorine in presence of anhydrous aluminum chloride. This is called halogen carrier, means it can help to generate the electrophile, and the hydrogen atom of this benzene molecule replaced by chlorine plus HCl. This is your chlorobenzene, and it is one type of electrophilic substitution reaction. Next, you can also make it bromobenzene. When benzene is treated with bromine in presence of anhydrous aluminum bromide. So this hydrogen atom gets substituted by the bromine. This is called bromobenzene plus HBr. Similarly, we can make iodobenzene by using benzene react with iodine. Mind it, this is a reversible reaction in presence of anhydrous aluminum bromide and in presence of a oxidizing agent like HIO3 to make the reaction irreversible. So it will form iodobenzene. Okay, students, and fluorobenzene is cannot be prepared by this direct halogenation due to the high reactivity of fluorine. And these are known as what reaction? Substitution reaction. The hydrogen atom is substituted by halogen. That's why it's substitution reaction. This is called electrophilic substitution reaction. This is called example of electrophilic substitution reaction. Okay, students, These are one of the method of preparation of chlorobenzene, bromobenzene and iodobenzene from benzene. That is, the benzene is treated with a suitable halogen in presence of halogen carrier, that is anhydrous aluminum chloride, anhydrous ferric chloride, anhydrous zinc chloride, even in presence of iron fillings. Okay, next come to the method of preparation of from benzene diazonium chloride, that is BDC. What is this benzene diazonium chloride? So, diazo means a molecule having nitrogen double bond. This is called diazo. What is this benzene? Benzene means C6H5 phenyl group. And benzene diazonium chloride, that is, this is your plus, this is your minus. Sorry, this one will carry the positive charge. And this is called benzene diazonium chloride, is one type of salt, that is diazonium salt. And this benzene diazonium chloride is used to synthesize the various class of halobenzene, that is, you can prepare chlorobenzene, bromobenzene, iodobenzene as well as fluorobenzene from benzene diazonium chloride. So, the benzene diazonium chloride can be synthesized from aniline. What is aniline? Aniline is a benzene derivative of ammonia or ammonia derivative of benzene. So, what is this aniline? So, you know, this is your benzene and one of the hydrogen atom containing amino group. This is called aniline. So, aniline is the amino derivative of benzene, and this is when treated with NaNO2 plus dilute HCl at temperature 0 to 5 degrees C, and this group, it changes to the diazonium group, the N double bond N plus Cl minus. This is called BDC, benzene diazonium chloride. And the conversion of aniline to BDC, benzene diazonium chloride, is known as diazotization. What is called? Diazotization. Means first the aniline is converted to benzene diazonium chloride. And the conversion of aniline to benzene diazonium chloride is known as diazotization. Means formation of diazonium salt. Okay, from this benzene diazonium chloride, we can synthesize the chlorobenzene, bromobenzene, iodobenzene, and fluorobenzene, etc. And the preparation of the chlorobenzene, bromobenzene, preparation of chlorobenzene and bromobenzene from BDC by two methods. That is, one is called Sandmesh reaction and Gattermann's reaction. And the Sandmesh reaction or Gattermann reaction almost same. The starting material is same, the product is same, but the reagent is small difference in the reagent. So, How can you prepare the chlorobenzene, bromobenzene from benzene diazomium chloride? So you take the benzene diazomium chloride N2 plus Cl minus, and this is when treated with HCl in presence of Cu2 Cl2. HCl in presence of Cu2 Cl2. Cu2 Cl2 means cuprous chloride, and cuprous chloride always in dimer, means two molecules are exist together. So the BDC, that is benzene diazomium chloride, when treated with HCl in presence of cuprous chloride, this group will be replaced by Cl and N2, and this is your chlorobenzene. Okay, students, that is this diazonium group is converted to Cl by the action of HCl in presence of cuprous chloride. Similarly, if you want to prepare bromobenzene, that is you treated with HBr in presence of Cu2 Br2, that is called cuprous bromide, so it gives you bromobenzene. And these two reactions, that is formation of chlorobenzene, formation of bromobenzene from benzene diazonium chloride, by using this reagent is known as, the reaction is known as Santosh reaction. Means Santosh reaction, we can prepare the chlorobenzene and bromobenzene from which one? Benzene diazonium chloride. Okay, student. Next, if this can also be converted into the chlorobenzene bromobenzene by another method, that is called Gattermann's reaction. The Gattermann reaction, the starting material is same, the product is same, only slightly difference in the reagent what you use. And the difference reagent what you use here you are using this one, you see this is use HCl in presence of copper powder. What is the difference? In that case you are taking cuprous chloride, but you are taking copper powder. Similarly, in this case also, prepare you treated with HBr in presence of copper powder, and this method is called Gattermann reaction. Okay, students, what is the difference in Santosh reaction and Gattermann reaction? In Santosh reaction and Gattermann reaction, difference is the starting materials are same, the product also same, only difference in the reagent. In Santosh reaction, you are taking the cuprous chloride, but in Gattermann reaction, you are taking the copper. Here also, HBr, cuprous bromide. In place of cuprous bromide, you will take the copper. Okay, students. Now, this is one of the method of preparation of chlorobenzene and bromobenzene from benzene diazonium chloride. And the same iodobenzene can be synthesized from benzene diazonium chloride by the action of, suppose benzene diazonium chloride treated with aqueous potassium iodide. When you treated the aqueous potassium iodide, this group is substituted by iodine. It became iodobenzene plus N2 plus what you get? HCl. That is, the iodobenzene can be prepared from benzene diazonium chloride by the action of aqueous potassium iodide. Okay, the fluorobenzene can also be synthesized. What benzene? Fluorobenzene is also be synthesized from benzene diazonium chloride by action of what you action? Hydrofluoric acid in presence of BF3. You take the mixture of these two, this gives you HBF4, and this compound is known as fluoroboric acid. When benzene diazonium chloride treated with fluoroboric acid, it gives you fluorobenzene. Benzene. Are you clear? And this reaction, the preparation of fluorobenzene from benzene diazonium chloride, this reaction is called Balch-Sisman reaction. What reaction? Balch-Sisman reaction. Sisman's reaction. So you see, in this preparation, we come with three type of name reaction. One is called Sandman's reaction, Gatterman's reaction, Balch-Sisman's reaction. And what is Balch-Sisman reaction? In this reaction, the benzene diazonium chloride can be converted into fluorobenzene by the action of fluoroboric acid. Means HF plus BF3. Okay, students. Now there is some question. Can you convert aniline? You starting suppose aniline. Now the aniline is converted into a certain compound A, and this compound A is converted to chlorobenzene, is converted to bromobenzene, is converted to iodobenzene, is converted to fluorobenzene. This is your chlorobenzene, this is your bromobenzene, this is your iodobenzene, this is your fluorobenzene. By using a suitable reagent, in this case you are using B, in this case C, in this case D, in this case E. You see, in this question we can convert aniline to chlorobenzene, aniline to bromobenzene, aniline to iodobenzene, aniline to fluorobenzene. Means first this one is converted, that is NaNO2 plus dilute HCl at 0 to 5 degrees C. It give a compound A, and the compound A treated with B gives chlorobenzene. Compound A treated with C, it gives bromobenzene. Compound A treated with D, it gives iodobenzene. Compound A treated with E, it forms fluorobenzene. Now, what is this A, B, C, D, E? What is? Identify A, B, C, D, E. What compound these are? So, can you answer now? This is your BDC, benzene diazonium chloride, and this reagent is your HCl in presence of a copper. It is HBr in presence of copper. You may use in place of copper CuCl2 and CuBr2, and this is aqueous solution of Ki. This is fluoroboric acid. try to answer yourself, and if any doubt, you can ask me. Okay, student, this is the second method of preparation of chlorobenzene, and in large scale, the chlorobenzene can be prepared commercially, what will require a large quantity. The large scale means synthesis. Can be prepared, chlorobenzene can be prepared from benzene. That is, you take benzene that react with HCl in presence of oxygen, and the catalyst is CuCl2. This is catalyst, and this will be converted into chlorobenzene. And this method is known as Regix method. Regix methods. RASGIC, Regix methods. Okay, this is about your method of preparation of chlorobenzene or halobenzene from benzene as well as from benzene diacetyl chloride. Okay, let's come to the properties. Particularly, you will study the properties of chlorobenzene and halobenzenes are colorless liquid and insoluble in water but soluble in organic solvent. The melting point boiling point increases from chlorobenzene to iodobenzene. Okay. Now come to the chemical properties. In chemical properties, we will study the two reaction, that is nucleophilic substitution reaction. Another is called electrophilic substitution reaction. What is this nucleophilic substitution reaction? What do you mean nucleophilic substitution? The halogen atom substituted by a nucleophile. But the chlorobenzene or halogenes does not show nucleophilic substitution reaction so readily. Meaning, like our alkyl halide, the halogen atom is not substituted so easily. That's why alkyl halides are very reactive, whereas haloarenes are least reactive, means almost inert at ordinary condition. You can ask, sir, there is also a carbon halogen bond. Here also carbon halogen bond, whereas that one is very reactive. Why not this one? And the haloarenes are least reactive toward SN reaction. There is three reasons. The least reactive of haloarene towards SN reaction. Mind it, very important this one. Least reactive toward reaction. One thing come to your mind, the reactivity of alkyl halide depends on carbon halogen bond. Here also carbon halogen bond. As compared to the alkyl halide, the carbon halogen bond in alkyl halide very weak. It can break easily, but in this case it cannot break so easily. Why it is not break so easily? We can explain. You see, suppose this is your chlorobenzene. Now, this is your carbon atom, this is another carbon atom, this is another carbon atom, this carbon atom, this carbon atom. You know, this carbon atom possesses a pi bond. Means, this carbon atom, it is a sigma bond, is equal one pi bond. Means that carbon atom contains 3 sigma bond and 1 pi bond. If it contains one sigma bond, this is called sp2 hybridized carbon atom. In alkyl halide, the halogen atom bonded to a sp3 hybridized carbon atom. But in aryl halide or haloarenes, the halogen atom bonded to a sp2 hybridized carbon atom. And the electronegativity of sp2 hybridized carbon atom is more than the electronegativity of sp3 hybridized carbon atom, because it containing 33% S character, this containing 25% S character, more the S character in the hydrogen orbital, more is the electronegativity. So, as compared to sp3 hybridized carbon atom and Cl, the electronegative difference is less, it's more as compared to the halogen atom bonded to a sp2 hybridized carbon atom. So, first reason, small difference in electronegativity between carbon and chlorine. Due to small difference, that is less polar and less reactive as compared to alkyl halide, because in alkyl halide the halogen atom bonded to a what sp3 hybridized carbon atom. There is large difference in electronegativity, but in this case small difference. At this small difference in electronegativity, that's why less polar and what less reactive as compared to alkyl halide. Next, small bond distance. You know, sp2 hybridized orbital is smaller than as compared to sp3 hybridized orbital. So when the carbon atom undergoes sp2 hybridization, the distance between the carbon chlorine is less than distance between the carbon chlorine in alkyl halide. When the distance is small bond distance means that is more attractive force and stronger the bond. If the bond is stronger, it requires more energy to break it. So, as compared to alkyl halide, to break the carbon hydrogen bond, it requires more energy, means it is less reactive. Another reason the chlorobenzene can exhibit resonance. It can exhibit what? Resonance. If the chlorobenzene undergoes the resonance, it can form so many resonating structure. You know, you can draw the resonance structure. Suppose the another resonance structure, this bond come to here, it is double bond, and this bond come to here, this became negative charge. So this became double bond Cl plus, because the pair of electrons used for the bond points are this bond, and this getting the negative charge, having a pair of electron. This is the two other bonds. Due to resonance, the carbon chlorine bond is what bond? Double bond. And more energy is required to break the double bond. If more energy required, what will happen? The reactivity is less. This means less reactive than the alkyl halide. That's why generally the halogen atom which bonded to the benzene ring is not reactive at all. Means it does not undergo any kinds of nucleophilic substitution reaction like aliphatic alkyl halide or alkyl halide. Are you clear? This is important. Why the halogen atom in haloarene is inert, it's not reactive. Means we have to describe these three different small difference in electronegativity, because the halogen atom which bonded to carbon atom in benzene ring is sp2 hybridization. So small difference means less polar, less reactive. Next comes to small bond distance, that is the bond strength depends upon the bond distance. If the two atoms are distance apart from each other, then we can see it is more reactive. When it comes closer, the attractive force is more, the reactivity is less. Then it can exhibit what? Resonance. Due to resonance, the carbon halogen bond possesses partially what charge? Partially double bond characteristics. And to overcome this double bond, it required more energy to break it. So as more energy required, the reactivity is less. Okay, so I will give a question, draw a structure. Suppose a compound is given to you. Suppose such compounds are there. How many halogen atoms in this compound? There is 3 halogen atoms. Suppose this is your A, this is your B, this is your C. And out of the 3 halogen, 3 chlorine atom A, B, C, which is more reactive and why? Means this compound containing 3 chlorine atom. This chlorine atom are different. And this one is A, this is B, this is C. You see, this is aliphatic in nature because this is bonded to sp3 hybridized carbon atom. This is bonded to sp3 hybridized carbon atom, but this one is sp2 hybridized carbon atom. So this halogen is called haloarenes or chlorine atom, which is bonded to the benzene ring. And if this now come to these two, between these two, these are aliphatic in nature. And this is primary, this is your secondary. Between primary and secondary, which will more react? The secondary is more react. So reactivity order between A and B, reactivity order towards SN reaction is B is more reactive than A because this secondary, this is primary. What about this? This is very least reactive because it bonded to a benzene ring. Then you are C. Means when you treated with aqueous solution of potassium hydroxide, this will be give immediately OH group. After this one. And this never give any OH group, means this never be substituted by OH group. Okay students, now the reactivity of halobenzene can further be increases if another substituent present in the benzene group. For example, suppose this is a compound. You see the halogen are bonded to benzene ring and the benzene is substituted 3 nitro group. This is known as 2,4,6 trinitro chlorobenzene. And another compound two 4 dinitro chlorobenzene. And another compound 4 nitro chlorobenzene, and another compound is simply chlorobenzene. It is seen that towards the SN reaction, the reactivity order, this is very reactive, means this Cl group can easily substituted just like you are aliphatic alkyl halide, then this one, then this one. Because when a minus or effect group, this group is called what? Minus or effect group. NO2 group is minus or effect group. is present in the benzene ring, the reactivity of chlorobenzene increases towards SN reaction, because due to presence of the nitro group, you can withdraw the electron. When this withdraw the electron, this carbon atom deficiency in electron by resonance structure, you can draw the resonance structure. When this one is draw the deficiency electron, means it can easily carry the positive charge. When this carbon atom possesses a positive charge, automatically this electron cloud, the carbon chlorine electron cloud, move toward the chlorine, and as a result, the chlorine atom possesses negative charge, not the positive charge. When the chlorine atom possesses the negative charge, that can easily substituted by a nucleophile. Okay, students, actually the chlorobenzene does not undergoes any SN reaction if the benzene ring of the chlorobenzene is substituted by a nitro group, that electron withdrawing group, the reactivity is increases. Okay, students, and the SN reactions. Okay, students. This much today. We will discuss the ending this chapter in the next class, class number 8. And in this class, we will discuss about the. What do we discuss? We will discuss about the what is haloarenes, means chlorobenzene, bromobenzene, iodobenzene, how these halobenzenes are named in IPEC system as well as in the common system. Next we will discuss the nomenclature. Next we will discuss the method of preparation. The chlorobenzene, bromobenzene, iodobenzene and fluorobenzene can easily prepare from benzene diazonium chloride, and the benzene diazonium chloride can be prepared from aniline, but that method is called diazotization. Okay, the chlorobenzene or bromobenzene or iodobenzene can be prepared from benzene by halogenation. Okay, that is the halogenation, the iodination, the formation of iodobenzene from benzene is a reversible nature. To make it irreversible, we are using some oxidizing agent like HNO3. Okay, and large scale the chlorobenzene can be prepared by Razik's process, that benzene treated with HCl in presence of oxygen and a catalyst, that is cuprous chloride, all the benzene get converted into chlorobenzene. Okay, we have discussed some nucleophilic substitution reaction. In nucleophilic substitution reaction, give the difference between the alkyl halide and aryl halide. We have to explain, we have already explained the halogen atom in chlorobenzene is inert, means not reactive. Why it is not reactive? Because the halogen atom bonded to a sp2 hydrogen carbon atom. Small difference in electronegativity and small bond distance, and last one is can exhibit the resonance. Due to resonance, the carbon halogen bond is a double bond, and to break the double bond, it requires more energy, means less reactive, and by resonance, the halogen atom, that is chlorine atom, possesses a positive charge, and the positive charge species cannot be replaced by a nucleophile. Again, the reactivity of chlorobenzene increases when the benzene ring possesses a electron withdrawing group, means minus or effect group. and the number of nitro group increases, the reactivity also increases. Okay, thank you students. This much today, and go and practice and watch the videos. Thank you.